Hello, um, here's video number 2. We're going to work through a practice problem. Fill in the table for the following situation. A researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. So let's fill in all the possible outcomes of this situation. Again, we would be doing this before we actually run the study, as we're planning our study from the beginning. I always go back to innocent till proven guilty. Our null is innocent, our alternative is guilty. Our null is our status quo. Again, pause this, try to do this on your own, what have you. The status quo is that this is just a generic question. I don't know what these vitamin pills are. All vitamin pills are not created the same. A lot of times it's the combination of vitamins, what have you. This is just an example. But the assumption is that these vitamin pills are nothing more than Tic Tacs, or chiclet gum, if you will. So the assumption is that these vitamin pills do absolutely nothing. I'm going to even write nothing. Let's write nada to be fancy. Nada. And here's that the vitamin pills do something, but we need evidence to support that they do something. So I'm going to focus on our context clues. Using my active pencil will increase. So another way to view the alternative hypothesis, another reason why it's so useful to use the alternative hypotheses to draw your normal distribution curves, is the hopes and dreams of this researcher lay within the alternative hypothesis. This is what they want. This is the status quo. They are the David going against the Goliath, the status quo. So what we want to do is the alternative hypothesis. This researcher hopes that these pills increase the weight. Notice they say average. So we know average is our mu, because we're looking to challenge the status quo mu. I've even seen in some instances where they will use mu sub 0, mu sub a. This is the mean. We want to challenge that. We want to say we can raise the average weight, because the more a baby weighs, generally the better, until you're like at 30 pounds, then God help you. So I want to say here for my alternative hypothesis, we are going to increase average weight. And here I'm just going to say nothing. Nothing happens. Weight isn't increased. Technically, it's not decreased either. But this is another reason why we start off with the alternative hypothesis. I'm going to set this alternative hypothesis using some inequalities in my mean sign. Let's say we have the mu. We want the average weight to increase. So our mu is greater than this value. Oops, made a mistake there. Our mu is greater than this value. That does remind me, again, the null hypothesis, h sub 0, is equal to, less than or equal to, greater than or equal to. Our alternative hypothesis is not equal to. If this is less than, it's greater than. This is greater than, it's less than. Below, we will have more practice, but remind you, equal to goes through here. This always lacks an equal to sign. So we want to say that we will actually change this. So whatever this weight is, it will be greater than whatever we're trying to deal with or process. So if this is going to be greater than that weight, this needs to be less than that weight. And that's how we set this up. So let's start this fresh. We want to say that the mu, or whatever we're working with, whatever pounds we're working with, our mu will be greater than, we're given an average weight of 8.6 pounds. And again, we try to start with the alternative hypothesis because this is the end all be all of this researcher's hopes and dreams. So if the researcher hopes and wants the mean to be greater than 8.6 pounds, the nada, the nothing, the status quo is that mu is less than or equal to 8.6 pounds. So if you want to increase the average weight at birth, for the alternative, the null is that it's everything but. And just to do a quick sketch, so we're used to these sketches, normal distribution, shading in the direction of my alternative hypothesis. So when we run a test statistic, if our test statistic lands here, we can say there's evidence or the significance to support accepting the alternative. However, if our test statistic lands here, there's evidence that supports remaining with or accepting the null. We lack evidence to accept the alternative. We reject the null, the alternative, and we stay with the null. Accept the null hypothesis. Let's just now run through our table. Nothing happens here, or mu is less than or equal to 8.6 pounds. So if we run through and accept the null, and this is true, we made the right decision. Okay. So we run our research, whatever data we get, we have evidence that encourages us to continue to accept the null, the status quo. That means we made the right decision. We're not going to have people spending their money buying vitamins that don't do anything for them, giving them false hopes, spending money needlessly. In this case, though, the researcher does not get to market, support, does not get to achieve their dreams. The researcher does not get to put pills on market. Folk don't waste money. But that's the right decision in this case, because in this case, if the null hypothesis is true, that means we ran the research and the average baby weight was not greater than 8.6 pounds. It was just normal. They might as well have just been taking sugar pills or doing nothing. However, if we run this research and based off of, if we properly sample and randomize, we get a test statistic that leads us where our average baby weight based off of our test statistic is actually greater than 8.6 pounds. If that actually happens, we would actually be here. If the weight or the pills actually increase the average weight of babies and we properly reject the null based off of our test statistics, we're here, the pills work. The researcher can, the researcher can publish anyway. Publishes significance. Just because you're not significant doesn't mean you can't publish. People, if it's not significant and it's good enough research, you could publish it and people go look at that, see what maybe you did wrong, change it, and then redo it again. But in this case, it's significant. They can market it. It's FDA approved. The FDA does this all the time, where if it's FDA approved, that means we ran it through a rigorous research process. We tested it. It's statistically significant, and we can release it and tell people, yes, it actually does increase the weight, and it's been proved, versus something that hasn't. Just if it hasn't gone through this rigorous analysis, doesn't mean it doesn't work. We just haven't found evidence to support it or not support it. It hasn't been run through the ringer like we need it to, so we can have faith or confidence that it works. Here are our errors. This is automatically type 2 error, type 1 error. A type 2 error is that we say that the pills do nothing when they really do. Say vitamin pills do nothing when they really do. They really do increase weight. So people miss out on that opportunity to maybe improve the health of their babies. The researcher doesn't get their glory and their fame, but that's why you have replication. You can always go back and research again. Um, in this case, though, you're saying the pills, when you reject the null, when it's true, you're saying the pills increase the weight when they really don't. So again, you're wasting people's money. In this case, they don't waste the money. In this case, they're buying it and you're wasting people's money because we have evidence to support they do nothing. Yet we're saying that they do. And when we have an alpha 5%, there's a chance that this can happen the same way there. Say pills work when they really don't. So for example, let's say we ran research and I don't know, 50% of our subjects, the babies did increase weight. But through the luck of the draw, through randomization, those people could have also started some interesting diet. Then they could have been taking, I don't know what people do for the babies to increase weight. They could have been drinking more water or what have you. You could be doing it around Thanksgiving time, Christmas time when people naturally eat. Now, I don't know a correlation between how much people eat and the baby weight, such is life. But the baby gaining weight has nothing to do with the vitamin pills. There's so many other confounding factors. Okay. So again, we've already discussed when a type 1 error occurs. A type 1 error occurs, we say the pills work when they really don't. And a type 2 error occurs when we say the pills do nothing when they really do work. Okay. And again, a type 2 error is what we would call a false negative. And a type 1 error is what we would call a false positive. I'm going to fill this in, but I think we already get the gist at this point in time. If you hear a cat crying in the back, that's my cat Harrison. And oh, I owe him canned cat food in about 15 minutes, so he's reminding me. But he'll wait till I'm done with this video. So we say that mu is less than or equal to 8.6 pounds. Remember, your null always has an equal sign. Your alternative is that the mu is greater than 8.6 pounds. When we shade our graph, we shade in the direction of our alternative. So this is pointing right. Harrison, stop it. Okay, so I'm going to shade here. It's a right tail test. Again, in terms of word problems, remember equal to. You can also say is in equality signs or is not if they say something is or is not. Greater than, more than, less than. Your null hypothesis always has an equal sign in it. And lastly, we're going to just work through this. Pause this video if you want to. This handout is provided next to the link for the video on the Google Classroom page. Try to work this out if you want to try it on your own. Pause it if you need to. Since the researcher shows that the mean pulse rate for the population under study is 82 beats per minute, the hypotheses for this situation are So the solutions here, notice they said is, so you know it's a two-tailed test. So the status quo, the null hypothesis, is mu equals 82 beats per minute. The alternative, if you want to challenge that, is that mu does not equal 82 beats per minute. So we could say it's a little bit more. Maybe it's 83, maybe it's 81, but it's not 82. And that's what we're talking about. That's what we're dealing with. We're still dealing with the z-score, except now standard error, we have n because it's based off of a sample. And lastly, just to leave you another reminder of our null and alternative hypotheses, they are typically always at odds. If null's less than or equal to, the alternative is that it's greater than, they want to attack and bite each other. If null's greater than or equal to, the alternative is less than, they're walking away crying or whatever. If the null is equal to, the alternative is not equal to. Okay, that's the end of this side. See you later.